In this video lesson, what we're going to talk about is graphing lines that are parallel and perpendicular through a given point. So let's go ahead and get started on this first one. It says graph a line through the given point and is parallel to the line shown. The first thing you have to do in these problems is to plot this point. That's why we provide it for you. If I'm graphing a line through the point, I have to be aware of where the point's located. So the first thing you always want to do is plot the point. So this is an X direction and this is Y. So I'm going to go left 1 and down 3. Next, I need to be mindful of whether or not I need to keep the slope the same or do the opposite reciprocal. And in this example, it wants the line parallel. Remember, parallel lines have the same slope. So all we're going to do is find the slope of the original line. And in this problem, our original line is located here. The way that you count slope is from point to point. And it's always going to be change in Y over change in X. That's one thing that we tend to mess up is we write Y over X, but then we count it X over Y. The best way to help you do this correctly is to count in the Y direction first, then count in the X direction. So I'm going to start here. I'm going to count up 1, 2, 3, 4. Up 4 is a positive 4. And then I'm going to count right 1, 2, 3. So my slope is 4 over 3. I counted up 4 and right 3. Since I want the slope parallel, I'm not going to change it. I'm going to go ahead and graph this slope, and I'm going to plot that slope from the point that we plotted originally. The reason we're starting at this point is because we want our line to go through that point. So I'm going to count up 4 and right 3 from the point. So up 1, 2, 3, 4, right 3, 1, 2, 3. Remember, you need a minimum of 2 points to make a line. So you don't want to just freehand this and go, oh, this looks parallel. You want to make sure that you actually have 2 points. And you have to start at this point because the line has to go through it. Then all I'm going to do is go ahead and connect my 2 points. And they are now parallel. This next example, we're going to work on perpendicular. So it says graph a line through the given point and is perpendicular to the line shown. So our point that we're provided with is -3, -1. That is the first thing you have to do, plot this point. So -3, -1. Now in this problem, I want perpendicular slope. In order to find the perpendicular slope, I need to first know what the original slope is. So I'm going to do the same thing I did with parallel. I'm going to find the slope of the original line. Because I can't make it perpendicular if I don't know what the original line is. So again, it's change in Y over change in X. So I don't get confused, I'm going to count in a Y direction first. So I'm going to count up 1, 2, 3, 4, 5. And then right 1, 2, 3, 4, 5. So my slope ends up being just 1 or 1 over 1. To help me with perpendicular, I'm going to keep this slope as a fraction, so I'm going to keep this as 1 over 1. Next, I need to be mindful of how I want to graph this. So this problem refers to this line needing to be perpendicular. So what I'm going to do, I'm going to take the 1 over 1 and I'm going to make it perpendicular, which means I flip it and change the sign. So when I flip 1 over 1, it's obviously going to stay 1 over 1, but my sign is going to change. This was positive, this is negative. So I'm going to graph my new perpendicular slope because I flipped the fraction, changed the sign, and I'm going to graph that slope from this point. That's why we have that point. We have to be mindful that our new line has to go through point -3, -1. So I'm going to count down 1, right 1. So down 1, right 1. Down 1, right 1. I could continue doing this, but I only need a minimum of 2 points. I have those 2 points, so I'm going to go ahead and connect. Remember, I need to start at the point -3, -1, because my line has to go through that point. And if you're having trouble on slope, go ahead and watch that video on how to calculate slope and how to count it. And also in that same video, we talk about how to do perpendicular and parallel lines. On the very last example, this is a review. We have done these before, graphing perpendicular bisectors. We weren't too great at them, so I went ahead and added it to this chapter just to get some extra review because it is on the state test and it is very important. So we want to graph a perpendicular bisector of the segment shown. Perpendicular bisectors do two things. They cross the segment at 90 degrees and they go through the middle. So the first thing you have to do is find the midpoint. And for the most part, some of us can look at this segment and identify that the middle is here. If you cannot look at the segment and know where the middle is, that's okay. All you have to do is use the midpoint. So let's go ahead and start. I'm going to find the value of these pieces. So 1, 2, 3, 4, 5, 1, 2, 3. So the location of A is -5, -3. The location of B is -1, and then up 1, 2, 3, 4, 5. I'm going to use the midpoint formula. So even if I do not remember or know where the middle is just by looking at it, the midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2. I'm going to add my x's, divide by 2, so -1 minus 5 over 2, comma, -3, or 5 minus 3 over 2. All I'm doing here is I'm adding the x's together, which those are my x1, x2 values. And then I'm just doing the same thing with y. So I've got my 5 and my -3. Those are my y2 values, so I'm just adding those together. If I'm going to type this into my calculator, I am more than happy if you do that, but you have to make sure that you're putting the top in parentheses. So if I'm going to do this, I'm going to do -1 minus 5, close parentheses, divide by 2, and I get -3. You have to put it in parentheses or your calculator is only going to divide the -5 by 2. So be careful. So I'm going to get -3. And if we do that over here, parenthesis, 5 minus 3, close parenthesis 2, we get 1. So our midpoint is located at -3, 1, which is exactly where we graphed it. So again, if you can't just find the midpoint, you actually have to calculate it. So bisector means you need to find the midpoint. Now I need to make my slope perpendicular. So what I'm going to do is count my slope. So that's the second part. I need my change in y over change in x. It is your choice if you count from A to the midpoint or from A up to B, or you could count B to A or B to the midpoint. It doesn't matter. I'm going to just go from A to the middle. So my y direction, I'm going to go up 1, 2, 3, 4. So my y direction is 4. My x direction is positive 1, 2. I'm going to go ahead and simplify this. 4 over 2 simplifies to 2 over 1. You do not have to simplify it unless you just want to. Now in this problem, it does want to make the slope perpendicular, which is very important. So that means we have to take our slope, flip it, change the sign, opposite reciprocal. So when I make this perpendicular, 2 over 1 becomes 1 over 2. This fraction is positive, so this fraction is going to be negative. So I'm going to graph my perpendicular slope, and instead of graphing it from just a random point like we did here, I had a point I had to start at. In this problem, the point you have to start at is the midpoint. You have to start at the midpoint. So when you are graphing this, there you go. You have to start at the midpoint. It's a perpendicular bisector, meaning it goes through the middle. So I'm going to count down 1, right 2. Now that I have 2 points, we're going to go ahead and connect. And that is your perpendicular bisector.